Okay, so greetings all. This is Amritanshu, and I wholeheartedly welcome you all to this final edition of this small chit chat that we have been having for the image processing as far as the different astronomical objects are concerned. And without wasting your time, I shall just take the name of two different softwares that we have taken in the course of 2 days that we had a small discussion with each other. The first day it was for learners at the beginners level, where everything was taken in a manual pattern with a lot of concepts that were discussed, fundamental concepts, in fact, that were discussed with the help of the auxiliary tool of micro observatories, NASA's micro observatories, hosted by Harvard and Smithsonian's JS94L, that is JS9 software for learners. Then yesterday we proceeded to another software of you can say more sophistication in terms of methodologies and the commands available, that was SAODS9. And today we are going to dive further deep into a very unique of its own kind of software, which not only helps you to calibrate your frames if you have got the calibration frames as well as the raw frames, but at the same time it provides you the opportunity, or in fact the facility, to develop a very great you can amount of expertise in the field of creation of RGB images or RGB channel. So now let me just turn on my picture in picture out mode view, and let me start presenting the screen for you. So I have just shared my screen. I hope my screen is slowly becoming visible to all of you. Are you all able to see the screen? Okay, anybody can say?
Yes, yes,
Sure. Thank you,
yes.
ma'am.
Yes, sir.
So today in the journey that we had seen, we are just moving to this third software of SIRIL, which is specifically an astronomical image processing tool only. And as all the other softwares that I have taken, this is also compatible with all the common forms of systems that people they really operate upon: Linux, Windows, and Mac OS. And even Windows also portable form it's available, as well as it's available for uh, any you can any specific software mode as well. So this is one of the advantages of all the softwares that we have chosen. And mind you, just I would just like to tell you one more thing, that SIRIL 1.06 version, that they may say it may contain a little bit of, you can say, instability in terms of release. If you read the release notes and all the things, don't worry. And you can choose the software which you are comfortable with. I am not going to put any compulsion that this has to be, this has to be, this has to be. And since it's under development, so what happens is more or less the commands in different versions may be little here there, or the language may be different, as we saw for SAODS9, but nonetheless the proceedings will be on a similar pattern. So I request all of you to kindly download SIRIL. It is not much, it will not take much of your efforts to download SIRIL, and it is just like a very simple any other software. So now let me just open this software in front of all of you. So this is that version of SIRIL 1.0.6, and today, you know what we are just going to do is we are just going to process that same image. You remember M42 that we did in SAODS9. So the same image we are going to process today, and with the help, before we are progressing into the processing of that image, I just would like to show you the way in which we have to organize our image before we go for processing, especially in SIRIL. So this is M42. So what we have to do is we have to compartmentalize our FITS files. Okay, compartmentalize means all the blue have to be in a separate directory, or folder, whatever word you are using. R have to be in separate folder or directory, and V, that is the green files, they have to be in a separate directory, or for that sake whatever filters that you are choosing, they have to be put up into separate directories. It cannot be like this, the way in which yesterday we tried to operate with NGC 2244. So SIRIL is adopts very scientific approach. So you need to compartmentalize the data, and as you can see, I have also put it in three separate folders. Now coming back to SIRIL. So the first thing that you have to do is you have to set a directory of operation. Now this directory of operation is the folder or the directory which contains all these three subfolders or any other subfolder, for that sake, those many filters, that many filters, those many folders. So right now it's RGB because it's an image processing software. So I have to select that image processing directory. So I will go to my softwares drive, and in that it's under the image processing, and my directory is okay, not this. I will just go a step back because I just went inside. So here it comes, image processing, this is yeah, image processing, and then I just have to make a single click, and after that I just have to click open. Now my home directory is set. Now what happens is I have set my directory or the place from where this SIRIL shall be taking the data, shall be uploading the data from. Now if you can see, there is a very definitive way in which this SIRIL software operates. It's very simple, you can say, but still it has got its own complexions. SIRIL actually works with the sequences of the image, stacks them, then make three color channel out of those images. So first of all, we need to identify the sequence, we need to make the sequence. So you can see towards the right, this is where the conversion tab, you can see where it's being written. So you just have to select this conversion tab, and from this plus menu you have to add all the files of same color to this. Okay, so let me just begin, let it be B. Let me just choose with the start with the blue files. Select all the files using Control A, or you can import one by one, or even drag and drop is also possible, and you just have to add all the three files. As you can see, all the three files, they have become visible into this conversion tab. Now what you have to do is you have to give your sequence name, because this sequence it is going to operate upon, and it is going to stack the images, and then you subsequently you will be performing this RGB coloration from this sequence only. So very simple, I am just giving it as capital B because it's a blue filter, no specific very large name, anything. And you just have to see that when you are doing this, has to be fits images. Okay, it's not a fits sequence, and this symbolic link has to be ticked upon. And now you just have to click on convert, and what you just have to see is a process will run, and you can see within a few seconds the three files, they have been processed. And as you can see, this is the blue file as it comes up in front of your screen. Needn't worry. Okay, now you come back with this arrow up. Here it comes in the sequence conversion, and now you have already added your sequence. If you want to verify, you can just go to the sequence. You see b.sequence folder has b.sequence has been generated, and to verify if anything extra has been generated, if we just go back to that folder, you can see b sequence has been generated, and this sequence constitutes from three files. So these four new files, they have been generated of late from this SIRIL. Now what we have to do is either we can proceed by these three files on a single go, or we can proceed with the filters one by one. So since we have got only three filters with three files each, so I shall create all the sequences one by one, and then we will proceed for the further steps. So blue is done. Repeat the same process. First of all, remove these uploaded files from the sequence before importing anything extra. So cross it, all the files will go. Again go to add, and from this folder it was B that was taken first. Now you have to go to R and select all the three, add these files. Just take care to rename the sequence, and my sequence is RP according to the filter name. So I have given RP, and all the things by default it fits images. It will take symbolic link is there, and then click on convert. So the three files they are converting, and again you can see in the console window you will see the things running, and as you can see, they successfully a sequence has been created, and consequently 4 files have been created in that particular folder as well. So let me just minimize. You can see this RP sequence have been created, these 3 folders. So now coming back to the conversion tab again and removing these files, and now what I shall do is I shall upload the third remaining one, that is the green filter. Control A and add them. Now the moment I add, I have to change the sequence name, and this is V or G green. So we are we are doing scientific processing. Let us choose V, and we are converting it. And once all these 3 processes are being done, and so it has read the files in 2.44 seconds, it has again produced a third sequence which is known as the green sequence file. Now coming back to the conversion, let us close all these files. And so this is the final way in which the 3 sequences have been created with the fits file in the FIT format which have been brought up. Now these sequences we are going to make stack of. From these sequences we shall be making a stack of. Now what has happened is, first of all, let us choose the sequence that we want to work upon. Okay, so we shall choose the sequence B or the blue sequence. Okay, and no need for any pre-processing right now. This is the advantage actually. If we are working on the raw file, then you can upload the master bias, master dark and master flat, and which even LCO also provides, and we can even use the offset dark and flat, and accordingly it will process the image as well. Okay, and that output can be used for stacking, but right now we are already working upon the reduced file frames, so we need not worry about this pre-processing. You can skip it. Now comes the registration. Okay, so in this sequence we have chosen the B sequence. Now here comes the science part. It is not simply anything that we have taken any image from anywhere. This is an image that has been taken from a certain portion of the sky. So what we need to do is we need to see that, ensure that all the stars that have been captured in the image, they are matched with the astronomical coordinates, and they are registered so that we can stack them scientifically. So what we need to do is we need to select register all the images. Then the basic is there are different algorithms that can be running, but global star alignment is the best one. Let the registration for a time being for our requirement, you can just click on and it will show you the different alignments, how what does they mean. If you want to dive deep, then the registration layer, let it be luminance, and if you want to prefix any put any prefix before this sequence, so that you can decide. And after you have seen all these things, just you have to simply click on go register. So it is registering in terms of the global star alignment. You can see the stars have appeared. Now it has registered all the stars in this particular, and it has closed this sequence also. And you know, one extra file has been generated at the moment. Okay, no, not at this moment. Sorry, not at this moment. But it has registered the stars. So after I have registered the stars, the next point is not the plot. I am not concerned with the plot, but here I just have to go for stacking. Okay, first just make ensure that now the sequence will change. It will change from B dot sequence to R underscore B dot sequence. Okay, and then you can stack. And with the stacking, the basic method that you have to do is you can select average stacking with the rejection. This is one of the basic commands that are available. Then Winsorized sigma clipping. Just take care that for a moment we are using Winsorized sigma clipping. There are scientific reasons. and then this will generate a stacked file in the fit format for you, and I shall just click on start stacking. Now you see stacked file has been created using this and this memory. So within 4 seconds a stacked file has been created. Now you see for blue file a fourth file is appeared. This is the stacked file. Okay. So similarly, now what we have to do is we have to repeat this entire process for come to the sequence, or then you change the sequence from RP, we had worked upon P, now you change the sequence to V dot sequence, and you register all the stars that are within this image. So the image will also start changing correspondingly. Here you go all these selected global star alignment, luminance and all these things, prefix let it be R underscore, don't change for a time being, or if there are too many images or so, then you can change, then click on go register, and it will start. You can see the stars are being found out on this image. At the left you can see how it is matching up, and sequence is being generated. And similarly we can either stack the sequence right now, right out, or we can come back to it later also and selecting the proper sequence. But since we have done the registration, let us stack it and then go back to the third one. So we will start stacking. It will stack the image and it will generate a stacked green filter file. Okay, now let's change. Now since the green signal means it has successfully executed, any problem, then it will come in red if it happens. Now what we have to do is we have to change the sequence. Okay, so from blue has been done and green has been done. So now the red, I think the red is the only sequence that's remaining. Yes. So RP sequence is the sequence that's remaining. So we are registering this RP sequence and we click on go register, and it automatically again is finding out everything for you, the stars that are known, and then any failure, everything is reported and all the things are there. Now what we have to do is we have to stack and start stacking these sequences. So here it comes, it is stacking all the 3 fits files, and within 5 to 6 seconds, as you see, the moment we are increasing the amount of the load on the software, per image becomes bulky, the time execution it also takes more time. So you can see now we have got 3 blue stacked file we have created, red stacked file we have created, and then correspondingly the green stacked file also we have created. Now just look at this R underscore, okay, R underscore P, R underscore RP and R underscore V. So don't look for the other files for a time being. So these are the important files that we need to worry about. Now in the meantime, if you want to see how your images they are looking like, so what you can do is you just have to select the sequence. Okay, for example, I want to see how my red sequence file is looking. So RP file is there. So here the file will change, and you come here, you make it logarithmic, or the best is you go for auto stretch. So in the auto stretch you can see this is your data in the red RP dot sequence. To see the blue data you go to blue, and it is again auto stretch. This is your data in the blue. If you want to see the green, then you see V dot sequence. Don't go for R underscore. It's V dot sequence. You see this is the green data. And the important thing is that this is only just a preview of your image. Okay, this does not affect anything or any data about the image. It has automatically been scaled until and unless you go for any special data. And you can see 3 out of 3 images it has stacked, and all the 3 images it's giving you a cumulative response in terms of green. It also shows 25%, or all those scientific data is being really shown. So now here we have come, we have done the stacking also, we have selected the sequences and everything has properly been done. Now coming to the final part, we need to have 3 individual color channels first before creating an RGB image. Now we are going to create a color channel, and go to this image processing tab, and in the image processing tab you just come down, you shall see RGB compositing. Okay, I am not going to go into other details, there are lots which can be done, but we are just going to go for RGB compositing, and here you can see image compositing comes. So just in front of the red, okay, you just have to select your stacked red file. Okay, so just go to this, go to that particular directory. From the source image, you select the RRP stacked file. Okay, stacked fit. You have selected the stacked file. It will now load. It will take little time. If it's having any problem, then it will not say okay. And you see the resolution of the stacked file 3054 by 2042. Okay. Then you come to what was the second one? It is green. So you come down and where you see RV stacked fit, you just go open and you select your green fit file. And then what you do is you come to the blue, the final channel that's remaining. You select that blue stacked file. Where is that blue stacked file? Yeah, here is blue stack.fit. You click it on in open, and all these three blue files, they are being done. Now what you do is, what has happened is actually these files, they have been put one after the other. The files they have been chosen now, but still what has happened is these three files, they are not aligned. Okay, they are not scientifically aligned, you can say. So what you really can do is, first of all, you need to align these images. Now towards the right, you can see there are two methods that are displayed in the terms of the alignment. One star registration in the deep sky and image pattern alignment. So let us save a little bit of time and let us select image pattern alignment for a time being. And before making this image pattern alignment, you just have to click a portion at the center of this image. Okay, a portion at the center of the image with your mouse. And then what you have to do is you have to click on align. So it will align all the three images accordingly. So it's aligning. Let it take a little bit of time. Now all the three image alignment has been done. And now comes the time for us to see what has been the result. So I have not taken any special thing while doing. I have just imported, just tagged for you, and just I am showing you the RGB. So now just I have to click on this RGB and you see this image. This is a combination of all the three frames. Those of you who have seen the micro observatory work, compare this SIRIL with the micro observatory. Okay. Those of you who have seen SAO DS9, compare that DS9 with this. So that is why I specially kept this software for day 3 as a special treat, New Year treat for all the people who persist to my chit chat listening for 3 continuous days. Then lot of adjustments really can be made depending upon the options that you explore. You can go for testing the color balance. All these things I have not tested yet. You can go for histogram or the curve tweaking. Toolbars are there. You can stretch. You can go for background neutralization. And at the same time, you can crop whatever section of the image that you require. You can do noise reduction. You can choose which bit format you want your image to be, and all these things, they really come under image processing. And it's not mandatory. My final comment for this series is, it's not mandatory that you always have to work with 3 images or sequence. Say if you have more than 3, the more the merrier, or in fact the better, because the more images you use, the deeper you will, the depth you will gain. You will gain a huge depth in the quantum of the data, and then you can save this datum accordingly in a different name, current image in a different name, whatever you want, and in whichever format you want, BMP, JPEG, PNG, TIFF, and any other software format which you want, you can export this image. Or at the same time, if you want, you can really save this image from here as well. So this particular portion is for visualization, and you really can work upon the things. In the logarithm, this looks like this. In the squared, the same image looks like this. In histogram, this will look like this. So it depends how much you are tweaking this image and the data according to your use. So export it, then try it in the GIMP software or Photoshop or even that Lightroom and try to give more luminance. This is just at a very preliminary level. I have not done anything extra or applied any particular filter. So this is what that all I had to discuss with you all. Thank you and thanks for maintaining your patience for being with me for 3 continuous days. Now I open the discussion and wish you a very happy new year on the New Year's Eve. So was it so boring that
No,
nobody
no,
is
no, 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 no. It was very good. I loved it.
Very interesting software.
sure.